Great, thank you
Great.
very much. This is the first time that I've done one of these presentations with a hybrid online and in-person audience. I'm usually one that really likes a dialogue back and forth as far as, questions and talking about what it is that I'm talking about. I do have the Q&A and the chat open on my other screen here. So if you do have questions as I'm going through things, feel free to put them in the chat. And if it's relevant, I will try to answer it at the time. But thank you for the introduction. My name's Carlin. I work at a place called City of Hope, which some of you may know, some of you may not. And so I'm going to give a little bit of background about that and a little bit of background about what it is that I do at City of Hope. So to start, what I'm going to be going over today is what City of Hope is, my personal path as far as going from the USF Master's Data Science program to City of Hope and nonprofit healthcare in general, because this is not the only hospital that I've worked at. I'm going to talk a little bit about the team that I work on here, which is the Applied AI and Data Science team. There's two portions of that I'm going to focus on. One is clinical decision support, and one is kind of AI research as a whole. From there, we're going to talk about some of the tech stacks, some of the workflows, some of the data sources that we work with, and then some of the challenges and learning experiences that you get in the hospital and nonprofit healthcare environment that I think are very unique. So first, I'm going to start with what is City of Hope? So City of Hope, this is, these are not necessarily my slides. These are slides that they kind of go over when you first onboard to City of Hope, and I'm going to kind of present them to you as well. So City of Hope is in Duarte, California. If you don't know where that is, it's about 45 minutes to an hour kind of east from downtown Los Angeles. It started in 1913. It was originally a tuberculosis treatment center. What the idea was that the dry desert air was really good for treating the symptoms and side effects of tuberculosis. And it was a free, non-sectarian, anyone was allowed to come and get treatment. By the 1940s, there were antibiotics to help, treat and reduce the impact that tuberculosis was having. However, City of Hope as a whole continued to stick around. The hospital was still there, right? And so they changed their focus to cancer. They also have divisions that work on diabetes research and treatment and HIV and AIDS research and treatment. They have the focus that, health is a human right. It's a very humanitarian vision to try to work on these particular things. And one of the early leaders of City of Hope has this particular quote here, and you'll see the gate that this is kind of plastered on at the campus. But the quote is, "There's no profit in curing the body if in the process we destroy this whole." And that is something that, the main, aspects of City of Hope's day-to-day treatment are, really embodied in that statement. So what does City of Hope look like in 2022? I pulled this picture from Google, and I've never seen Southern California, the desert, look quite that green. But that's a picture of City of Hope's campus where the main hospital is. There's also 30 plus outpatient facilities that are in the Southern California area where, there's outpatient visits where patients go and get treatment. There was also a recent acquisition of Cancer Treatment Centers of America, which has hospitals now, California, Georgia, Illinois, and Arizona. We also have a genomics research facility named TGen in Arizona. And there are some other outpatient facilities and some other aspects that we assist with throughout the country. So how did I end up at City of Hope? So I got reached out to by Diane to talk about this a bit, because I think I have a little bit of an interesting path in that almost all of the work that I've done both at USF and since USF has been in the public sector, right? And so I wanted to talk a little bit about what my background is, how I ended up, you know, working in Southern California at a cancer research center. So I did my undergrad at UC Santa Barbara. I studied statistics and psychology. A lot of what I worked on was research focused, right? Developmental psych research, user-centered design. There were a couple of publications that I assisted with there. And while I worked there, I also worked on some mentorship and tutoring programs at the United Way of Santa Barbara. Following UCSB, I joined, I believe it's cohort 5, for the master's in analytics at the time, master's in data science program at University of San Francisco. My primary practicum for, I think, 7 of the 9 months was with BART, Bay Area Rapid Transit. I worked on ridership forecasting. I worked on, interactive dashboard to kind of assist them with some of their ridership forecasting on a month-by-month basis for 12 to 24 months in the future. After I was done with that program, I moved back to Los Angeles, which is where I'm born and raised, and I joined Children's Hospital Los Angeles as a data scientist on their virtual pediatric ICU research team. This team used recurrent neural networks and LSTMs to analyze ICU and cardiothoracic ICU data. I'm going to be using some medical terminology, and I'll try to explain it more when I get to more of our data sources, but that's kind of what we focused on in CHLA. In 2019, I joined City of Hope. They had just opened up an applied AI team. And since I've been at City of Hope, I've worked on both publications and applications. And I am now leading the clinical decision support data science team as of 2021. So let's talk a little bit about what applied AI means, what that looks like at City of Hope. So this may be similar to some tech companies. This may be something that's a little bit more unique to City of Hope. But again, I wanted to kind of give the broad picture of where AI and data science lives at City of Hope. So we're under the digital vertical. We're in the same ballpark as, some of your more standard things like IT, enterprise business intelligence, information security. But there's a couple divisions here that are, unique to our hospital environment. We also have informatics, which works on like digital health applications, clinical applications. Some of it is, note processing or working on the systems that kind of feed in some of that information that the end users, doctors and nurses might utilize in their day-to-day. We also have precision medicine data and systems, which really focuses on, really high fidelity data. It could be imaging, it could be genomic gene processing, and they work on the systems in the back end to, capture and aggregate that data for us. And then there's us, which is the applied AI and data science team. So what is it that the applied AI team does here? So we have 3 teams and kind of one broad overview of things that we like to look at. So I manage the clinical decision support team. So we work with doctors and nurses to make real-time data-driven decisions to try to improve quality of care, reduce cost of care, and improve patient experience. We also have a research and precision medicine team. This team works very closely with that genomic research team that I mentioned earlier. They focus on cancer prevention and treatment. They look at biogenomic imaging, clinical and socioeconomic data, both within City of Hope and with publicly available data sets. We also have a business operations and finance team. This team is probably closest to what you would see, at a finance firm or a tech company that is focusing on operational efficiency and effectiveness. This is financial modeling. This is forecasting. This is, trying to optimize the day-to-day operations internally and the strategic initiatives that kind of align with that. And then the last one here, which again, I'm going to touch on the 2 underlined ones more later in the talk, is kind of overall AI and ML innovation. And so while we are the applied AI team, what we end up doing is a mix of research and application. And so what we try to do is we try to do the full process of taking something from a research concept, applying, those techniques and strategies to our data sources at City of Hope, and to try to see if we can apply them and turn them into, products that we can use internally to, help clinical care, help any of the categories above that we're mentioning. And so from there, let's talk about what clinical decision support projects look like. So here's a picture of myself that was, I think, taken at USF. I think I still use the same picture. And so let's talk about, what it is that I do along with my team that's pictured here. We want to work with clinical teams directly to assist with real-time decisions. And so when I say real-time decisions, we do have the ability to do things that are, nightly batches or, email notifications. But what our goal is we want to feed back information directly to the end users and as real time as possible. And so that is our overall goal that we're trying to do. Some of the things that we're trying to do is we're trying to improve quality of care, we're trying to reduce the cost of care, and we're trying to just kind of help streamline some of those systems that, feed into clinical applications. The other aspect of this is we want to monitor the patients. This is primarily for inpatient applications. Inpatients meaning patients that are staying in the hospital rather than patients that are coming to the hospital for appointments or coming to the smaller satellite sites for appointments. We want to monitor patients for unwanted conditions and outcomes. This could be ICU escalation, sepsis, other clinical anomalies that we're trying to avoid in their treatment practice. And we also really want to focus on long-term initiatives of the hospital as a whole. So what this is these are kind of overall standards of care that we want to help improve at the hospital, that are metrics that hospitals are compared and assessed and evaluated by on a national and international scale. This could be reducing readmissions within a 30-day window, meaning a patient was discharged from the hospital, they went home, and then they had started having side effects or some other illness that required them to come back into the hospital for an inpatient stay again, right? That's something that gets tracked and measured, and that's something that we want to try to avoid. There's also some interesting optimization problems, right? Especially in the last couple of years, hospitals have been very strapped for resources, for beds being available, right? And so one of the things that we want to try to look at is, well, are we using our beds that are available in a optimal way, right? Are we making sure that there aren't just open beds that are, needing of cleaning, right, before a new patient can come in? Are we making sure that we aren't keeping patients at the hospital longer than we need? That's a very interesting optimization problem. That's something that we work on. A couple of the other ones here, inpatient capacity, I kind of touched on. Reducing severity of illness, I touched on a bit earlier. Making sure that we're really, trying to catch some of the anomalous conditions that patients might develop in the hospital earlier to try to implement preventative care and treatments. And so again, let's talk about what some of the data sources are that my team focuses on. Now, this is not every data source that is used at City of Hope, right? I did mention, genomic data, genomic sequencing. I did mention imaging data, so that could be MRIs, magnetic resonance imaging, that could be X-rays. So if you've ever seen, deep learning, brain scans or, chest X-rays or something like that, that is doing that image processing, that's not necessarily something that we are focusing on in the clinical decision support side of things right now. We're really focusing on the clinical vitals and related data that we see. So let's talk through our main categories of data sources. So the first one that we see here is vital signs. So vital signs would be, your heart rate, your blood pressure, respiratory rate, anything that, if a nurse comes in and is checking on you and is checking how you're doing, those are the things that they'll document. We also have laboratory results. So if you have blood drawn, if you have, some sort of, condition that they're checking for, they're checking to see if you have an infection, they're checking to see if, a treatment is effective. They're going to draw blood, they're going to go, process it, and that's the kind of laboratory results we'll be looking at. We also have a lot of data on medications. There's two categories for this, really. I'm actually going to start with the second one, which is orders. For those of us that have been to a pharmacy or something like that, it's the same concept. There's a prescription that gets written up that would be approved for this amount of dosage, this number of pills, this amount of time. We have that information available, and we also have the actual administrations. So each time an IV is put into a patient, each time a pill is given to a patient, each time fluids are administered, right? All of the administrations of individual medications are data that we also have available. This fourth one here, admit discharge transfers, ADTs. So this is any patient movement in and around the hospital or even with outpatient sites and facilities. So this is data that is saying, okay, a patient just checked in at this time, the patient is now being moved to this bed, the patient is being moved into a surgery unit, the patient is leaving surgery. We have that information available to us. And the last one, which we use for a variety of kind of mixed applications, is clinical notes. So this is actually probably one of our largest and most complex data sets, which is free text or templates that are filled in with information. So it could be a form that has, patient X has condition Y, where, you fill in the blanks, and then that just gets processed as free text, or it could be the doctor or nurse is just typing into the system. And so we use that for a variety of things. And again, we'll talk about that in a bit. So what does this data actually look like? In short, this data is really, really messy. This data is messier than any data that I looked at in grad school. This is messier than any data that I looked at my practicum for a variety of reasons. So some data is automatically entered at regular frequencies as it streams from electronic sensors. So let's think of this as time series data, right? If we're looking at, some data that is sequentially coming in over time and we're getting different levels over time. And so I put a diagram on the top right of this slide here, which is talking about, two forms of oxygenation support. So this is a really big category of data that we look at because oxygenation support, depending on the level, can be very invasive, and we want to try to make sure that the patient is getting their correct amount of support. And so something like this has a machine that is streaming information into the medical record. This is at a minute-by-minute basis. And so this is, regularly sampled, relatively clean. But there are, still some oddities with this, right? What is streaming from this electronic system might not be what is necessarily being documented or recorded by a nurse as the level of treatment. There might be some conflicts with those pieces of information. And there's also some inaccuracy, some cleaning up if systems are being changed or levels are being adjusted and how that information gets recorded. So it is a regular cadence, but there are some issues with that data processing. The majority of our data, though, is not automatically entered by systems or electronic machines. It's manually charting. And so what I mean by charting is, again, this is when a nurse or a doctor will go into the patient's room, check on the patient, and start entering information into the system manually. And so to kind of go over what is showing on the image in the bottom right, this is a fake patient, but this is what a medical record looks like. And they'll have essentially a spreadsheet of sorts that they're entering in information. This spreadsheet is actually cleaner than it shows in reality because this spreadsheet has units in it. some fields are not strict on units. So I'm not sure how big the displays are that you can see, but in the bottom right, there's one here that says pain. And that field just has a 0 in it. There's no units, there's no key, there's no definition or explanation of what pain means here, right? Some of these others are a little bit more strict. Some of them are automatically calculated. So you see there's height and weight, and then BMI is there. That's a field that's automatically calculated. But again, this data is irregularly recorded, right? This is as the patient is, being evaluated by a doctor or nurse. So this data could have some fields missing at certain times. This data could have units entered incorrectly, or it could have, if it's data that comes from a different hospital, the units could be different. One hospital could be measuring in inches, another could be measuring in centimeters, right? There's a lot of things to make sure that, data pre-processing is done properly to make sure that we're actually evaluating this. And the last thing here, most information is recorded as free text notes. Ultimately, there's only so many forms that can be pre-filled like this, right? There's only so many pieces of discrete information. There's not a way of us discreetly saying, the nurse had a specific conversation about treatment outcomes with the patient. That's not something that we're filling into a discrete field. And so most of the information that we have available is free text. And that means that most of the information is a variety of sources, and we have to really do some kind of either rudimentary processing or more advanced processing, depending on, what it is that we're trying to get out of it. So that's the EMR data at a very high level. I do think that there's probably some things that I've left out on this, but I do want to move on to what project and product development looks like at City of Hope, right? Because the projects that we work on come from a variety of sources, have a variety of partners and teams in them, and it really, really is a multidisciplinary collaborative effort to try to, take something from these raw data sources that are entered from a variety of means and have something that can turn into an application. And so let's talk at a very high level, some of the people that are involved in a project that we do at City of Hope. Most of this is going to look pretty similar to a tech industry team, except for the clinical aspects of this. So generally speaking, we work with subject matter experts. So we'll be working with nurses, physicians, advanced practice providers, right? We'll be working with some sort of clinical domain expert that can help us understand the data that we're working with and help us really define the problem that we're trying to solve and the solutions that we can try to implement for that problem. Our projects require sponsorship. So not sponsorship in the financial sense, sponsorship in the support to make sure that, they get integrated and utilized by their respective teams, right? And so for some of our projects, we've had support from the chief nursing officer, chief medical informatics officer, chief digital officer, different enterprise systems at City of Hope, depending on the particular avenue that we're working with. Kind of trickling down from there, we also have a lot of project leadership, right? The data science side of it is one aspect, the portion that, I focus on day to day. But, there's clinical informatics teams that work on designing the systems that kind of, interface our models with the doctors and nurses. There's enterprise applications that, help make sure that security is there. There's reporting teams that help build out dashboards for Epic. And I don't think I've mentioned what Epic is. Epic is our medical record system. So there's some, I think Epic is the most used medical record system. So there's reporting teams that are dedicated for the hospital for that also assist with, generating dashboards and metrics for us. There's enterprise data and data warehousing. We have a bunch of SQL servers. We have a bunch of data sources in a variety of places, and we have teams that help us aggregate that. And we have different teams that we work with. We work with our patient experience team that makes sure the survey feedback that we get from Press Ganey and other sources continues to be positive about our clinical workflows. We work with the digital innovation team to test out new kind of workflows and new kinds of ways of integrating digital health applications. And different clinical administrators from different treatment groups at the hospital to try to address their specific needs. When we're looking at our specific project team, the teams that are doing the specific day-to-day work, we have the data scientists, we have patient care services who are working on getting approvals for different workflows, again, informatics, reporting. There's training teams that are involved because not only do the models need to be implemented and developed, but the workflows need to be explained, right? That is one of the most interesting aspects of this. Is it doesn't matter how good our model is, but really it's the integration and how we interface it with the end users that's really the most important key to making sure that people understand and utilize what it is that we're offering. And again, there's an infrastructure component for it. Probably the most valuable team, our data engineering and architecture team, has helped us develop some of these pipelines that really allow us to have the infrastructure that we need in order to build these applications for us. So I was kind of asked to cover quite a few different things for this presentation. So one of the other things I want to go over we just talked about, the different teams that we've worked with internally to kind of work on a project. What I want to talk about now is some of the diverse technologies that we use at City of Hope. The different teams have different focuses on here. So what you don't see on here is, the precision medicine team primarily uses X, Y, or Z application on here. But this is an overview of a lot of the different resources and tools that we use in our day-to-day. And I'm going to go over some of them just at a very high level to kind of get a feel for that. So what I'm going to focus on first is, we use a variety of different primarily Python modeling and data manipulation tools, but we also, do have the use of, our studio. We do use, Shiny, so we do have a bit of that, but primarily with our precision medicine team, especially, that is doing, deep learning, image processing with very, very large models, very large, data sets. They're primarily working in, PyTorch or TensorFlow, Keras. We have on-premise servers and we have cloud deployments, so that's why I've kind of put this in the middle. We do, have our kind of suite of, data visualization tools that we have. We have, an RStudio Connect server and a Tableau server that are managed by different teams internally. And so we have the ability to develop, bokeh dashboards or Shiny dashboards. We have, your standard, SQL Server management software, right? We have Microsoft SQL Server internally. We are working on, cloud deployment of data warehousing eventually as well. So, standard fare there. There's a couple unique tools that you may see on here. So I want to point those out really briefly. We do have CI/CD tools, continuous integration, continuous deployment tools that we use for some of our projects. Data security is very, very important at City of Hope and at any medical facility in general. And so you do see that we have one that's cloud-based and one that's on-premise. There are different applications that are functioning in different places. And so we do have, those applications set up in two different ways. A couple of the other clinical focused things that we have on here, one is CorePoint. CorePoint is an integration engine. Essentially, I'll go over it in a couple slides, but essentially it's what drives all of our real-time systems, and it's how we get our real-time data out of Epic for all the vitals, medications, labs. The last two that I want to go over, DNA Nexus. DNA Nexus is essentially a cloud-hosted platform for our imaging and genomics data processing. So, you'll load up DNA Nexus, it'll open up, a Jupyter notebook with, PyTorch or whatever else in the back end, and you are going to be doing your data processing on these really large de-identified data sets there. The last one here is in Azure, we have a deployment of Confluent Cloud, Kubernetes, Apache Kafka, and this is where we do our real-time processing for our predictive models that feed back into Epic. So I kind of hinted at it earlier, we have our models that are trying to send notifications to doctors and nurses about conditions or anomalies, and that is our real-time system that we use to really make sure that that is happening in a scalable, efficient way for us down the line. And so I kind of already went over this. We have our data warehouse, our standard SQL databases, nightly ETLs, extract, transform, load. I don't know if you guys have taken the SQL class yet, but that'll be fun. This is appropriate for email-based pilots, things that we'll take a nightly batch query, create a nightly report, send out that information to an email. Really, that's what that is best suited for. There is a way for us to deploy models directly in our medical record platform as well, Epic's cognitive compute platform. There's some limitations for this, which I'm going to kind of glance over, but really we're limited on some of the ways we can pre-process data with that. It's something they're working on. But we also have the aforementioned, Confluent Kafka streaming platform, which allowed for us to really develop our own customized batch and real-time business applications that weren't really possible internally because of the limitations of our SQL databases and whatnot. So let's go over at a really high level what this system architecture looks like for us. What is it that we're trying to do? What is it that we're trying to develop with this real-time infrastructure for our clinical staff? So to walk through this at a very high level, we have doctors and nurses that are recording information in Epic. So they're at the bedside, they're at an appointment, they are seeing a patient, they record, this patient has a heart rate of 90. This patient is going and getting a blood culture. This patient has been administered ibuprofen and a couple other medications. Each time one of those events happen, a piece of information called an HL7 message gets sent out. An HL7 message could be thought of as a very compacted JSON. Essentially, it can be broken down into a JSON blob. And so each time one of those events happens, that gets pushed out of Epic via CorePoint. So Epic goes to CorePoint feeds it out to a bunch of other ancillary systems. One of the systems that receives this information is our cloud-based modeling, which is hosted in Azure. So we have a variety of pre-processing scripts that happens for our different deployment models, for our different pilots and production level models that pre-process this very messy data in some different ways, right? So for admit, discharge, transfer information, we'll have some processing that is trying to track, patient status, patient location, and time since admission, right? So there's some features that are just cleaned from the data, some that are pre-processed from it. For things like vitals or medications, we might be forward filling some of that information. We might be imputing, the administration based off of an order. There's different pre-processing that we're doing in microservices that live in Docker images in that real-time infrastructure. Eventually, once all of that data is pre-processed and aggregated on the patient level, for our different models, we can generate patient level risk. So we can say, this patient has a very high heart rate, this patient has a very low blood pressure, this patient has a high respiratory rate, and they're on oxygenation support. They're at risk of X, Y, or Z condition. A model that is trained generates that prediction and generates the feature importances. We typically use SHAP values for feature importance. So we're generating that prediction and that feature importance that goes out from the model and is generated in real time as these messages are coming in from the end user's charting information. This then goes out of Epic through some APIs that are sent to Epic again, and they trigger clinical workflows that are then based off of some given threshold, selected based off of precision and recall, and based off of other clinical determinants, will trigger advisories that I'm going to talk about in a minute, based off of the level of risk for a particular patient. So let's talk about those clinical workflows, because I realized I put BPAs there, but I didn't explain them yet. So BPAs, best practice advisories. These are pop-ups that will show up in the interface for a doctor or a nurse or a social worker or some other clinical staff that can advise the clinical staff of a particular condition or a warning or a risk of X, Y, or Z. And so there's a couple here for a model. Obviously, this is not a real patient. This is a test system that this data has gone through. But I want to walk through where the model component of this kind of is showing, and where the, where this is just kind of pulled from the medical record. And so we see in the, that is not the button that I wanted to press. We see in the top left portion of this, there's a portion that says predictive model details, right? It feeds in the score from the model, and then we have a section that is called factors contributing to score. This is kind of a static section that we kind of have jerry-rigged to feed in information from the model. So we can say percentages for, a particular feature. We can say, in this red one here where the text is a little bit clear, we can say, respiratory rate is 43. That is giving that is contributing 26% of the risk that we are seeing for this particular patient, right? That is integrated directly into these advisories that we are sending out to the doctors and nurses. But the rest of the information on here is just getting pulled straight from the medical record, right? So we're saying, okay, the most recent vitals for the patient, this patient had a blood pressure of this. This patient had a pulse or respiratory rate of that. These are the recent anti-infectives, right? All of that is designed by our clinical teams internally, because those are the things that are most relevant as far as pieces of information. So these BPAs that I'm showing right now are related to sepsis risk. Sepsis is a bloodstream infection, which generally has an impact to your circulatory and respiratory systems. And so you see a lot of the things that are displayed on here are related to, those systems, completely agnostic of the model, but really part of the design to make sure that, okay, we know that the patient is at risk based off of our predictive model. Let's make sure to present the information that is most relevant to our end users to, show them what they believe is most important to assess that. So we have what the model believes is important, and we also have, the clinically determined factors in here. The last part of best practice advisories that I want to go over are the portions at the bottom of this. Again, I don't know how big it is for you, but there's portions that say open order set or do not open at the bottom, the green buttons. And then below that, there's something that says acknowledgement reasons. And so what these two sections mean are essentially, these are the ways that an end user can interact with these notifications. They can say, okay, you know what? I agree that this patient is at risk for sepsis. I'm going to open up the order set and place an order for something to, try to treat and prevent this condition. Or, I see, okay, I already see that this patient is kind of showing the signs and symptoms of sepsis. I'm going to denote that sepsis treatment is already in progress. So I'm going to acknowledge that this BPA has been shown, and that is my perception, perspective of the situation that we have. And so really, that is how we can kind of track and evaluate a lot of what is going on the back end for these models, right? We know the times that these are displayed. We know the scores that are displayed. We know the factors that are displayed. And we know what actions are or aren't taken from this. So we can say, look, we can see that, these advisories are correctly showing for this proportion of our population for this treatment group. We can see that they're acknowledged in this way. We can see that order sets are increased in their utility early on, and we're seeing reduced severe sepsis rates or reduced ICU escalation, right? that is how we can kind of evaluate some of that. And there's a lot of complexities with, you know, how we can determine it is something that the model is doing, something that the workflow is doing, or something that is affected by other clinical staff. But really, you know, this is a really key way as far as how we can track some of the information of the utilization of the predictive models. On the next slide here, I want to add in, there are other places that this information can be integrated directly into the patient records that can kind of, you know, be displayed for the clinical staff. So this isn't, you know, part of their medical record, but this is part of, you know, what gets displayed for the end user. And so there's different displays that show up in Epic for different groups, right? So this floor of the hospital, which could be, you know, treating, you know, leukemia. This floor of the hospital could be doing transplants. Those different groups will have different lists of patients that show up in the medical record. And so we can feed in the information about the predictive models, the scores over time, and the factors contributing to the scores again, so that it's kind of accessible in another way, just at any time without needing to wait for the notifications to pop up. So really the information is available at all times. So let's talk about some of the applications that we've actually developed with this and some of the directions that we're kind of going with this. So, and all of these are, you know, either pilot or in production, and all of these are things that we have also published on in some way, shape, or form. So I believe I'm an author on a couple of these, but mostly it is the data science lead for each of these that, you know, is a first author on the publications for these. But let's go over at a high level what some of the applications that we've actually worked on are. One application we've worked on, which I've just touched on, is sepsis risk for transplant patients. So this is for bone marrow transplant patients. It can either be, you know, a transplant from a related or an unrelated donor, but it is a bone marrow transplant to treat, you know, cancer. And so we're looking at this as something where we're trying to notify clinicians when these patients are undergoing this particular transplant, because they have to be immunosuppressed. So they have to be put on immunosuppressants to suppress their immune system in order to take the new bone marrow transplant on, in order to engraft the transplant. And while they are very immunosuppressed, they are at risk for sepsis. They are at a very high risk for, you know, having a bloodstream infection. And so this notification system is something that we've had since June 2020. This is something where we are trying to send out notifications to doctors and nurses of patients that are at risk for developing sepsis or deteriorating for sepsis. And this is the project that I've had the most involvement with. We have a few other projects here. One is 30-day unplanned readmission. So again, I was talking about, you know, there's the efforts at the hospital level to try to just improve standards and quality of care. This is one of those efforts to try to predict unplanned 30-day admissions and to try to understand and assess some of the interventions. This is kind of a production pilot that we have been working on for a couple of years now. And this is something that, you know, there are some barriers to adoption for this, and some of those workflows still need to be developed, but this is something that we've been testing and evaluating. Another production level project that we've worked on is prognostication. Prognostication is essentially 90-day mortality predictions. So the goal of this project is to improve end-of-life experience for clinical staff, for the clinical staff and the patients that are working closely with the clinical staff, to make sure that advanced directives and goal of care conversations are in place. What this means is, if we have an understanding that, you know, there are some treatment strategies that we can do, we want to make sure that, you know, the patient's care and the patient's will is, you know, first and foremost in our treatment processes, right? And if we are concerned about the patient's status or prognosis, we want to make sure that we have those conversations and document those conversations as far as what the patient really ultimately wants out of their care, to make sure that, you know, we are doing what is the best for the patient. And this has been a relatively successful pilot. This is something that has been in play. This is not a pilot anymore. This is in production. This has been in place since February 2021. We also have one that is surgery complication risk. This is for unplanned surgery. So there's two types of surgeries that happen. There's your scheduled, come in a month's time. We're going to, remove this particular mass, or we are going to, do this particular procedure to improve your breathing, or whatever it may be. Those are planned surgeries. So there's a lot of time that can be spent, prepping and understanding the patient's condition. There are also unplanned surgeries, which, the patient is deteriorating. We need to make a decision of whether to do a treatment path or a surgical path to really, make sure that the patient is doing okay. And that is why we have developed a predictive model for it, because we wanted to assist the clinical staff in making sure that complications from these unplanned surgeries are kept at a minimum and that the risks are accurately assessed for these. The last one I want to go over is patient experience. This project is to understand and assess feedback that the patients have anonymously given in the past, to generate predictions that are provided in kind of a report form for our doctors and nurses and other clinical care teams, to try to make sure that they have an understanding of what things need to be addressed in particular types of visits, in particular places, in particular, settings. Different outpatient sites have different populations and have different kind of focuses of their care. And so this is really to try to surface this information and to try to predict the patient populations that might be at highest risk for having, negative experiences, and trying to address those early on. From this, I also want to kind of go over some of just broadly, the applications that I work on are very focused on the patient's medical record, but there are a variety of, technologies that we are exploring at a high level in our different groups to, kind of make sure that we are, fully applying our skill set to the different data sources at City of Hope, and B, trying to solve not just the shorter term problem, but the longer term data analysis and model development processes that we really are working on. And so to go over some of those at a high level, we have our real-time data infrastructure, which again is what's feeding those clinical systems that I just mentioned. This is hosted in Azure. This is Confluent Cloud with a Kubernetes and Kafka backend. This is Python microservices that are Docker images, right? That is really what is driving a lot of that. We also work on active learning tools. So, we evaluate active learning systems for medical image annotation and evaluate some of the use cases to try to improve and streamline some of the pathology and radiology workflows. Image annotation is a very time-consuming process. It is also kind of a flawed process, right? Sometimes, different reviewers might have different perceptions of what, an image might see. And so we've been working on active learning systems with that. We also evaluate and work closely with NVIDIA on some of their publicly available image analysis tools. So NVIDIA has a repository online where they have a lot of Docker images with different image, text, other kind of machine learning application, like kind of pre-built in Docker image. And we've been working on automatic segmentation and annotation of tumor images. What that is if you have a 3D model of an image, there's slices of it, and we want to try to automatically work on some of these processes to try to remove some of the manual annotation. Really, the main focus of a lot of what we do, I'm going to come back to the explainable AI one, which is the main focus. We also, work on some of the natural language processing, which is all of that note analysis. And we also have, a variety of different data sources that we look at. Different data streams have different quality, different fidelity, medical record change, practice changes. And so there's a lot of monitoring that we do over time. But ultimately what it comes down to is that other one that I've underlined, which is explainable AI, which really translating the importance and efficacy of a model to something that is understood by non-technical audiences and understood in a clinical application and a clinical setting is the most important thing that we work on day to day, right? It is very, very difficult for us to say, this complicated deep learning algorithm is doing this, therefore this patient is at this risk, right? We need to take steps back from there. We need to say, okay, how are we pre-processing the data? How is the data going into these models? How are we validating and assessing the models themselves? And how can we translate the way that those features are being considered into, a clinical application? That is really, really critical to what it is that we're doing and to making sure that our work gets accepted and utilized by different groups at City of Hope. So we spend a lot of time focusing on the interpretation of our model and our data sources. And so the last slide that I want to go over is some of the challenges. These are the things that keep the job interesting day to day. Honestly, I don't want to have these things be things that are scaring someone away, but these are the things that make it, interesting and worthwhile, right? Well, I've talked about it in the last slide, data drift from a variety of sources. There are changes in medical records, systems, or the recording strategies. A flow sheet, which is the thing where patients' data is entered into, can change. There can be changes in the clinical practice. So the order set has changed for X, Y, and Z condition. Now that means that order set usage has gone up or gone down. There could be a new study that says this condition should be treated this way. A lot of those things aren't directly explained in our data sources. Almost none of them are, right? So if we see, this form of oxygenation has dropped 30% in the last 2 months, we need to understand, why is that? Did practice change? Is a clinical system broken? Is a recording system broken, right? There's different teams that monitor some aspects of that, but really if it's impacting model, we need to have a good understanding of that. I also mentioned that the hospital is expanding. We had the recent acquisitions. We have new sites, it seems like every day. New hospitals mean new demographics, new patient populations, new focuses on treatments, new, case studies to try new treatments at different sites. And so each of those means that there's different data sources being added constantly. And then the last one, I mentioned recording mechanisms for data entry. There are different streaming systems that are being actively developed. Now some patients can access their medical records from their phones and, input and record data directly. There's a variety of different systems like that. And knowing where data comes from and how it's being entered and the accuracy of those sources and recording mechanisms is really important. To go away from data to the product development cycle, really the end-to-end product development cycle is very involved. This is not something where you're doing very quick, rapid A/B tests. This is not something where you are, running untested pilots to that could impact patient care without any, approvals, right? We work at a hospital, a very highly regarded hospital, and we need to make sure that everything is, every I is dotted, every T is crossed. We need to make sure that approvals are there from different committees. We need to make sure that if it's part of a research study, that a research board approves it. We need to make sure that we're constantly, monitoring and evaluating the efficacy of these models. And if there are any impacts to patient care, that we are actively reporting them, right? And so it means that the process to get to deployment is very involved. Again, it's very rewarding because we know that the outcomes of these are impacting patient care, and we're trying to improve patient care and patient experience and all of that. So really, it makes it worthwhile. I mentioned it already, limiting model permutations or evaluating efficacy. We don't have huge numbers. This is not Walmart. This is not, Amazon or Google. We are working with the number of patients that a hospital can see, right? And so there's only so many permutations we can do, and there's only so many ways to test the permutations, right? Again, we can run silent pilots, but we can't run A/B tests and things like that. So really, kind of limited in that part. And then the last part, which again is interesting, is the understanding of the domain knowledge. I haven't taken a bio class. I think I took one bio class in undergrad. I think it was like bio for psych majors. But before that, I think I took a bio class in 10th grade. It's been a while. I don't have a bio background by heart, right? But you learn the domain knowledge as you're working with it, right? You understand these clinical aspects of these workflows are related to this data. This is how to interpret these medications. This is how you understand the rates of these things. There's a lot of interesting things that you learn about the data that even for someone that does not have a bio background can learn a decent amount about with that. And I think that's really interesting that you don't need to have that background, but it really, really is something that as you grow in the industry in this kind of field, you really end up learning a lot about clinical care. That is very interesting, and has actually been very interesting to know in the last couple of years. That's my last slide. I really appreciate you guys taking the time. I know, this is a very interesting way of doing this, but I'm happy to take questions here. I know that I have the Q&A open as well. My email is there on the screen as well. I'm sure you can find me on LinkedIn or the Instagram page for this or whatever. So thank you guys for the time. I appreciate it.
Okay, so I think we do have some questions in the Q&A.
Mm-hmm.
All right.
I do see some streaming in. So I'll just kind of say them out loud and then I will kind of try to address them. So I'm going to do the anonymous attendees first. If I remember correctly, you mentioned limitations of the SQL database. What are these? Our SQL database is limited in a couple of ways. Mainly, it's not something that we have 24/7 access to as far as having up-to-date production data. So we always have a database that we can query. If production is being updated by our nightly ETLs, we can go and query our QA database or something like that. But it's also not updated in real time. It is updated with nightly batches. And so what that means is that if we wanted to do something with a real-time application or where time is of the essence of the application, we can't just query from SQL. And so that's the main issue that I have with it. Otherwise, I mean, the database works fine when you're doing retrospective work and things like that. Thank you for the question. The other question here, we're in a place in time where this so-called pre-processed data to clinical recommendation loop requires heavy human input and technical maintenance. When do you think we will settle into a more automatic, computer autonomous and closed loop place in the time for this work? What will be the pivotal innovations that get us there? So this is a big question. This is a good question. There is heavy human input and technical maintenance in clinical recommendation systems. And I wouldn't even say necessarily that what we do at this point is recommendation systems. What we do at this point is really early warning systems. Recommendation systems are another, advancement from there, because if we are recommending like patient individualized treatment plans or something like that, that part also right now would require heavy human input, and we would have a lot of complications with that. When do I think that we will settle into a more automatic, computer autonomous, closed loop place and time? I think, and the two hospitals I've worked at have been at different stages of their data pre-processing pipeline. I think what we have gotten close to at City of Hope at this time is we have a pretty good standard for how we pre-process a lot of our data. We have a pretty good understanding of what data has what accuracies or inaccuracies. And we don't need to do a ton of technical maintenance on the pre-processing portion of it. The portion that requires more human intervention still are the more complicated data sources, right? The text processing is still not perfect, and we're limited because it is just chock full of PHI, which is personally identifiable health information that we can't, outsource that to, a third-party platform or something too terribly easily. There's a lot of limitations to how we can process that. I think for text, we are getting there. I think for image processing in genomic data, we are still quite a few years away from that. As far as but I could see it, in the next 5 years or so, us really getting to a point where image processing and things like that are a lot more smooth. What would be the pivotal innovation that would get us there? Really, the problem that I see, so the two places that I've worked are very specialized facilities. I've worked at a children's hospital that is also a very acute care facility, right? If you have a very, very ill child that needs to go to the ICU in Los Angeles, they go to CHLA, right? And I work at City of Hope, which is a cancer care facility and is the one that patients go to in LA if they're very, very sick or need very, very new clinical trials, right? The pivotal innovations are, there are generalized models that work for some image processing, that work for some text analysis and things like that. Really what we need to see is them trained on more robust data sources or data sources that are closer to our specialized audiences, right? And there are ways that we can retrain some of these models, that we can try to use like active learning or something else to kind of adjust for that. But right now our sample size internally is low, and it's very hard to share very secure data between different facilities. And so the innovation for us to get us there is really data sharing and data collaboration between different sites and institutions to try to improve that. And things like DNA Nexus are kind of platforms to try to provide some of that de-identified information, but there's still a lot of work that needs to be done there. But good question, Caleb.
Thank you.
Any other questions, comments, thoughts about this?
So I have some questions, but I'm wondering if the students would like to ask. Yeah, go ahead and use the microphone. So if you can't hear it, I'll repeat the question.
Okay. I just want to ask, as an MSDS student, what would your recommendation for people who want to work in clinical decision or digital health to learn during this program? Thank you.
Great question. I think the thing to learn most, and this is going to sound really, really silly. I don't know if Nick Ross is still around, but I feel like this is a very Nick Rossy kind of thing. Is it's communication, and it is explanation and understanding of your data sources, right? I realize that's a very vague answer, but I talk to doctors and nurses every single day, right? My most difficult challenge is explaining and making sure there's a clear understanding of the strengths of a model, the weaknesses of the model, the limitations of the model, how it should be interpreted, right? It is really dependent on that portion of it, right? Making sure that you have a really clear, defined way of making sure that you can explain what is going on, that it doesn't have to be the most advanced data science, right? It doesn't have to be deep learning. It doesn't have to be fancy image processing, but you have to be able to explain it. You have to be able to communicate it, and you have to make sure that the data is being processed and presented in a way that is most clinically applicable and relevant. And so again, that sounds like basics, that sounds like fundamentals, but really ultimately that is what's most important in my mind.
Thank you. I think we had one more question from the queue, or two more questions from the Q&A.
Yeah, I do see. So Nathan, do you see an MS as a must for working in data science roles focusing on ML and AI compared to having to analytics, does having a health background have any relevance in helping you in your department? So for me, I do actually want to go talk briefly about me joining the Masters in Data Science program at University of San Francisco. For me, the program was a must for me. My research background and kind of theory background from undergrad was not sufficient for me to have the technical understanding and kind of application side of things that I got from the USF program. I would not have been able to kind of function in this job environment without that training. So I think, you know, the ML and AI portion of it, you know, the MS really kind of helped with that. For analytics, I think that an MS program, or, you know, the USF program is also very valuable. I just mentioned a ton about, you know, communicating and presenting and understanding analysis of results. And I think the program focuses on that very well. Making sure that, you know, whichever practicum you're working with whichever stakeholders you're talking to, you know, whether it's an internal or external audience, making sure that it is clear and concise as far as what you're doing. I think the program still does a very good job of it. I think it really depends on the definition of analytics. If you're talking about like just dashboarding, like, you know, making bar plots and like plots over time, I don't think it's as important. But really, you know, presentation and analysis of results, if you are working on the ML aspects in any way, shape, or form, it's so important. For the second question, I've kind of answered it already. Having a health background have any relevance in helping you? There are actually very few people on the team that have a healthcare background. So the full department is about 15 people. There's a couple people with biostats as a background. I think there's a biochem person, but like, you know, there's a PhD in physics, there's a master's in statistics, there's a couple other like kind of random odds and ends. I think there's an electrical engineering background, right? I think the health background helps my communication feel very natural. And I think it helps you get on the ground running much quicker. So I was able to, when I started working at City of Hope, I was able to jump into working on things like that because it didn't take me, you know, 3-4 months to figure out the data sources, right? I understood what vitals and meds and how they were processed were. I understood all of that from my previous work, but I think there are places that you can just work and learn that. I do see another question in the chat. It seems people mistrust the decisions computers make despite them doing that in many different fields. What do you think would be the best way to increase the trust in clinical decisions made by your models? So this is an interesting question because depending on the background of the clinical staff that I work with, some are very open and accepting of these ideas and, you know, trusting of us. Some, I definitely was asked in the last couple of weeks, you know, why do we need an algorithm to do the application or something like that, right? And, you know, I think the way to increase trust in the clinical decisions is to show metrics of efficacy in pilot phases. And so generally speaking, before we deploy any production level model, we do some sort of pilot that's either email-based or manual reporting-based or biweekly reports or something like that, where we walk through with the clinical staff and we say, okay, here's the time series prediction, plot of the predictions over time for the last 2 weeks for this patient. Here are the times that, you know, clinical interventions happen. Here are the times that the predictions at this threshold would have shown. You know, we kind of walk through some of the more skeptical like folks on a case-by-case basis like that. At an aggregate level, it's really a pilot where we are saying, okay, you know, we are trying to improve the number of goals of care conversations that we're having, right? We are going to pilot it with this willing department that is willing to try and test this. We're going to give it 4 months. We're going to get the results and say, hey, look, this department has increased their goals of care conversations by 27% since we've implemented this. Now let's roll this out to other groups and try it and test it, right? And so I think it's a little bit outside of evaluating the technical aspects of the model and translating it into the clinical and operational aspects of the models to make sure that there's a clear understanding of it. Good question.
Thank you. And we have a question from the audience here. Go ahead.
Hello, you mentioned a bit about explainability. I'm kind of curious if you could dive a little bit more into some of the metrics or tertiary models you use to help.
As far as model explainability, or as far as like evaluating the efficacy of our data? Could you be a little bit more specific?
Yeah, for like model explainability in terms of, like you have a neural network or even like a random forest, like how you explain what's going on underneath the hood to somebody when, the parameters aren't clear what it's doing.
Right. And so I don't have a plot with SHAP values on it, but so I did mention, most of the calculations that we're looking at are SHAP values, Shapley additive explanations, I believe. And essentially what we will do is we will look generally for models that are, real-time models, we will look at the patient level and the time step level. The time step being, whenever a new vital medication or lab comes across, the patient's state will be updated and the prediction will go through. And generally speaking, we try to map it to the clinical outcome that we're looking at, and we try to work with the clinical staff to see if the directionality of, say, the SHAP values is clinically relevant to the outcome that we are working with. So to give an example of that, let's say that I have a model that is trying to predict a patient's risk for ICU escalation, meaning that, the patient has to deteriorate in some way in order for, the model to say, yep, the patient's at risk for ICU escalation. If I have a model that is showing, increases in heart rate above 120, let's say, increases in heart rate are associated with increased risks of ICU escalation. That's essentially, I realize that's a dumbed down version of the explanation that you can kind of get if you really are looking at the weeds of SHAP values, but that's essentially the way that we have to interpret it and evaluate it, right? If the clinical intuition is, hey, patients should have if a patient has a heart rate above 120, they're looking not so great, then we are going to, say, okay, if this model that we're looking at matches these clinical, expectations as far as the directionality of the SHAP values, then we're doing okay. If it's something where we don't have that background knowledge necessarily, which are fewer or far between, but there's some that we could say, distance from a medical facility, right? It's hard for us to say, whether we expect, distance from medical facility for, some outpatient model that we're working on, whether more distance or less distance is the direction that we would expect, right? For those, we would really depend on the subject matter experts and the clinical teams or the operational teams that we're working with to provide information, right? So if we say, this model is showing that patients that are farther away from the hospital are actually showing increased satisfaction based off of distance. That might seem counterproductive to us, but maybe there is some sort of explanation that we can determine with that, right? They are satisfied with the experience because, they are coming to this facility because of their specialized treatment or care that they need. And therefore, because they're willing to make the longer trip out, it is worthwhile to them, right? Or it could be, this patient lives around the corner, but parking's bad at the hospital. And so even though it's less than half a mile away, we see dissatisfaction because it takes them 15 minutes to go half a mile because it's Los Angeles, right? It really depends on the clinical application. I don't know if I completely answered your question, but I think I gave you more than it's complicated. So that's kind of the way that I feel about it.
Thank you. And actually, the students are in the middle of choosing their practicums. They have to submit their choices by Sunday. So I was wondering, you had a slide earlier with technologies. Could you show that slide again? Yeah, great. So for this slide here, I was wondering which data experts use which technologies. For instance, I don't think the data scientist uses all of these, but maybe they do. And so which would you consider really good for the students to pick up now? And which would you say, like, if you saw this on a resume, you'd be extra impressed? So core skills,
Okay.
Extra impressive skills.
That's a very good question. So for day-to-day skills, right? Day-to-day skills, an understanding of Anaconda, Jupyter Lab, sklearn, pandas. I don't think I even need to go into detail as to how or why. I think that one's pretty straightforward. I don't really care about the IDE you use as long as it does the functionality. I don't care. I don't care what querying software you use as long as you have a good understanding of SQL. I know that is a very fun class in the program. You have to know SQL. You have to understand all of that. As far as other day-to-day technologies, I would hope, and I know this isn't the case for every practicum, right? It wasn't the case at my practicum at BART because BART is not a very it's not Google or Microsoft, right? Or Amazon, because the two examples that I'm going to give are some sort of AWS or Azure experience, right? It doesn't have to be full blown. I understand how to deploy a Kubernetes cluster in Azure, right? But understanding, this is roughly the idea of how you get data in and out. This is roughly the idea of, how to set up an environment, or how to make sure that, the environment is structured in a way that I can use it, or that the security is right on it. Even just at a high level, I think that's pretty important. Things that I think are really, really good. If you are someone that is not focused on research, that is more focused on maybe even, like the data engineering side of it, or the, like, what I would call ML ops side of it, if you've got something like Bamboo or Azure DevOps for like your continuous integration, continuous deployment stuff, that is really, really cool. That's really, really interesting. I don't know how much, again, really depends on the practicum. If ML ops and data engineering are your thing, those I would highly recommend. And if you are leaning towards the data engineering side of it, specifically like streaming data, I don't know if the coursework really covers it, but maybe a practicum or something does. Really something like Kubernetes and Kafka, not necessarily, full understanding of how to deploy an entire system, but understanding, this is a subscriber, this is a producer, this is, how the partitions work, this is how you integrate an API call with it. At a high level, if you're interested in the data engineering side of it, I would be very happy to see Kubernetes or something similar. The last part, and I realize I'm kind of saying everything, but I think I'm kind of focusing on the specializations. The last part, which I would find very useful, just kind of in a practical sense, if you at least have some sort of experience with some sort of visualization tool that is beyond Matplotlib, it's not a requirement, but it's a nice to have. I didn't really have a ton of, I did have a Shiny application, coming out of BART, but some sort of rough understanding of, this is how I would deploy a dashboard for end users to see it. It doesn't have to be a full understanding of it, but if you're more into the communication and presentation side of it, I think some sort of visualization tool would be interesting. I think I said everything on here except for Docker and DBT. Docker is very good if you want to make the people that you work with happy, making sure you understand Docker and Anaconda. And DBT has its uses, but it really depends on the place. So.
Okay, and how did you feel about like TensorFlow, Keras, PyTorch? How important do you think deep learning is right now?
I think deep learning is incredibly important, but if you're not doing that in your practicum or something like that, I would not feel like you are missing out. And I say that because it really depends on the industry that you're working in, right? For our clinical applications, we are not doing deep learning right now. No deep learning whatsoever. In the past, I have done some, right? But those were really researchy applications. And I think if you want to get into the healthcare space and you want to do research with imaging or genomics, then you got to do some sort of deep learning stuff. But I don't think the application side of it, at least in the healthcare industry, is there yet. I do think it's good to at least have a understanding of the, like, you know, CNNs, convolutional neural networks, recurrent neural networks, like at a high level. But for like what I do day to day, it's not a requirement. If you want to get into imaging or genomics research, yes, absolutely.
Thank you. Do we have any last questions? Yeah, we do. Okay, good question from the audience.
I have a couple of questions. Like, one is more of a general question, and the other is a data science related question. The first general question is like, how do you? Is it audible? Okay. How do you deal with the importance of your work? Like, the intersection of data science and health is amazing field. Like, the work you do has a direct positive impact on people, but at the same time, like, if you make a mistake or cause a delay, it means that less people are positively impacted, or there could be a negative impact. Like, how do you deal with that? Second question is the data science question. Like, how are some of the data science techniques or statistical techniques like different when applied in a medical context compared to other contexts? Like in our prop stats class, we learned that level of significance when using when doing it in a medical context is different because we want to reduce the margin of error. Are there similar such things? Like, I'm just curious.
Okay, so the first question, which is, you know, handling the balance of the importance of the work versus how I feel day to day. I'll just answer that by saying I sleep fine at night. Meaning that, you know, I'm not sitting worrying day to day about if the things that we do are really, like, you know, if there's an error that's harming people, because if we were doing recommendation systems or something like that, which generally speaking, depending on the system, require FDA clearance. If we're doing recommendation systems, recommending treatments, recommending paths of procedures, I would feel a little bit more stressed than I do. We're working primarily on early warning systems, right? Two separate categories of things. I do think with the recommendation systems, I mean, I already kind of mentioned, you know, it takes months in order for us to get a new model live. With recommendation systems, it would take even longer probably. But I think, you know, there is a bit of solace in knowing, you know, if you go and you have it approved by the research board, you have it approved by all of the internal committees, info and security has approved it, right? Compliance has approved it, right? If it has gone through all of those procedural tasks, and then, you know, it is finally made it to production, it's not all on your shoulders if there is a particular aspect that needs improvement down the line. it has been reviewed by a variety of people. And so I don't, I'm okay with that. I'm okay with that. Your second question, how is this different than other kind of data science fields, or like how is the day-to-day maybe different? The day-to-day is different because, and I've only worked in healthcare really, except for my little bit of time at BART. So I might actually find it a little bit hard to say this, but the amount of time that you spend thinking about this stuff, the the how and the why of it is a lot, right? If you're working in ads or something, there's at least an expectation and understanding of how that data gets in there, about the trackers, about the individuals that are being analyzed, their demographics, right? There's at least a rough understanding of that. With this, the amount of digging to make sure that you understand how different data sources are made available, how they're recorded, and what that implies for the end, care of the patient. I think there's a lot of time and energy spent on that. There's more time and energy spent on that than testing and training models. The models are actually not the most critical aspect of it.
Thank you. I think we'll end there. Thank you so much for your time.
Thank you very much.
Goodbye.
Thank you.